Hey Cheryl, so everyone's kind of buzzing about the quantum internet, right? But I gotta ask, is it just faster Wi-Fi? Because that's what a lot of people probably think.
Oh, Shannon, absolutely not. And that's really the biggest misconception. It's not about faster streaming, you know? The quantum internet, it's this whole different beast entirely. It's designed for super specialized tasks like leveraging quantum mechanics principles. Think instantaneous, like absolutely secure data exchange. It's a revolutionary network, but it's totally distinct from our current classical internet. It's for qubits, not classical bits.
Qubits. Okay, so what actually is a qubit then? And how does that make it so different? I mean, beyond just the name.
Right, so a classical bit is either a 0 or a 1, straightforward, right? A qubit, though, can be a 0, a 1, or both simultaneously, thanks to something called superposition. It's like flipping a coin and it's heads and tails until you look at it. And then there's entanglement, which is just wow. Entanglement is what Albert Einstein famously called spooky action at a distance. It means two qubits get linked, right? And the measurement of one instantly tells you the state of the other, no matter how far apart they are. This is key for quantum key distribution, or QKD.
Okay, so entanglement sounds wild. And QKD, you mentioned that. Is that where the absolutely secure part comes in? Like for real world stuff today?
Totally. QKD is the most significant real-world application right now. It lets two parties create a provably secure cryptographic key. Here's the cool part. If anyone tries to eavesdrop on that key exchange, it collapses the quantum state. Both parties instantly know the interception happened. It's practically unhackable. Companies like JP Morgan Chase and HSBC are actually already using it. And get this, China's demonstrated satellite-based QKD for intercontinental links. It's pretty wild what they're doing with it.
Wow, so banks are using it and we're linking quantum computers? That's fantastic. Are there actual networks starting to form, even small ones?
Oh, definitely. Beyond QKD, we're seeing incredible demos. In February 2025, Oxford University scientists linked two quantum processors, demonstrating first distributed quantum computing. This created a single connected quantum computer, a huge step for scalability.
That's amazing. So, connecting computers. What about city-scale networks?
Yeah, totally. In November 2025, IonQ, with a Swiss consortium, launched the Geneva Quantum Network. This citywide network uses existing fiber for experiments in quantum information transfer. It's exciting to see initial focused quantum networks emerge.
So, that sounds incredibly promising, Cheryl. But what are the big roadblocks that keep this from being a global thing tomorrow?
Good question, Shannon. The biggest enemies are photon loss over distance and environmental noise, decoherence, which collapse fragile quantum states. Also, we can't just amplify quantum signals like classical ones. We need complex quantum repeaters with stable quantum memory, a huge tech challenge.
Okay, so tech hurdles for repeaters and cost?
Exactly. The hardware, like ultra-cold refrigeration and single photon detectors, is immensely costly and complex. Widespread global adoption means a staggering investment. It's a huge hurdle.
Okay, so huge challenges for sure. But what are the practical applications? What's this quantum internet actually for in the long run? And when are we talking for a truly global network?
Well, future applications are mainly ultra-secure financial transactions and distributed quantum computing. By entangling separate quantum computers, they could form a single, vastly more powerful virtual quantum computer for solving complex problems.
So, big science and super secure stuff, not like quantum Netflix?
Absolutely not for Netflix. A broad-scale global quantum network, Shannon, is decades away, not years. It's a marathon, not a sprint. Its potential to transform information is just incredible. It's exciting.